Hey everyone, welcome to a new series. I'm calling it Real World Function Refs, and it's going to be all about looking at more real world applications of the function ref feature of Vue 3. I explored that pretty deeply in my other series called the Power of Vue 3 Function Refs, and I'll link that in the description because it's definitely worth checking out as kind of a prerequisite to this series. So in that series, I explain function refs, but I did it with kind of simpler, more contrived examples by necessity because I was kind of focusing on the core concepts more so than how do you actually use them. In this series, I want to get more into the exciting stuff, which is how do you take this very niche, weird feature of Vue, make it a little bit more ergonomic to work with, and then actually put it to work in our applications. So to do that, we are going to be relying pretty heavily on a tool, a function that I wrote called useElementApi. And let's go ahead and actually import that right now while I explain what it is and what it's all about. So we import useElementApi from @baliada/Vue features. So Baliada Vue features, this is my library of Vue composables that are basically they all run on function refs. They all do really cool stuff with function refs. There's like use listbox and use grid, use textbox, all these different composables that are designed to capture elements from the DOM with function refs and then just augment them with tons of different functionality, whether it's accessibility features or just more basic stuff that we need in any application. So useElementApi is my abstraction that I use inside that library to basically make it easier for me to create function refs and consume them so that I don't have to kind of confront those implementation details in every single composable that I write. So that's what we're going to be using throughout this series. So for this first episode, we're just going to kind of look at the details of useElementApi, explore how it works, explore what it can do. And then in future episodes, we're going to really get into the meat of the series, which is applying that and using function refs to solve problems in a way that is pretty sleek and pretty nice in a lot of cases. So we have some markup here, obviously. We've got a Vite app rendering some stuff on the screen. And I have broken this down into 3 sections on the screen here. We've got element, list, and plain. And those you can think of as 3 different data structures that useElementApi is designed to create for you and allow you to work with different types of DOM elements. So the simplest one would just be a single DOM element rendered on the screen. useElementApi can capture that DOM element and give you access to it so you can add event listeners or whatever else we're going to do throughout this series. Then list, useElementApi has kind of a list mode where it can capture a list of elements rendered by v4. And actually, let's poke around in the markup here to see where that happens. So if I scroll down here, yeah, here it is. We've got a list, v4 item, comma index, and list metadata. So we're rendering a list here with v4, and we want to get programmatic access. We want to get a function ref that stores the elements rendered out by this v4. If you have watched the other series, you've seen me do that a little bit, but useElementApi is a way nicer, cleaner way, especially when working with lists and anything more complex than that. It's really nice to have the useElementApi abstraction to deal with that stuff instead of having to mess around with the implementation details of dealing with update cycles and re-renders and stuff like that. So the final one here is kind of a bonus, and it's something that's very new to the Vue features, the Baliada Vue features library in general, and it's the idea of capturing a plane of elements from the DOM. And when I say plane, I mean like a 2-dimensional plane with an x-axis and y-axis. So that is kind of like the abstract term that I use to describe grids, tables, anything like that, where you basically have, a grid of elements. And in this case, those elements are rendered by a nested v4. So we have here in this chunk of markup, we are rendering, we're looping over rows, and we're saying v4 row, comma row index, and plain metadata. Each of those rows is also an array. So this whole data structure is an array of arrays. So we're first looping over the top level, v4 row in plain metadata, and then each of those rows itself is also an array. So we can iterate over those rows. So we can say v4 column, comma column index in row, and we can render out that way each of the cells of this grid. And I don't know if that makes total sense right now. Hopefully it'll make a little bit more sense once we start applying useElementApi to capture this stuff. And we'll do some console logging and stuff, and hopefully it'll become a little bit more clear how this stuff is working under the hood. Planes are I would say, like, less commonly needed, a little bit more advanced. Again, they're only for stuff like accessible grids and tables and things like that, which I think are a little bit less common data structures that you'll have to be working with when you're doing like day-to-day function ref work, or solving day-to-day problems that function refs are good at solving, maybe is a better way of saying it. So anyway, let's jump in and start getting access to these DOM elements. That's kind of the goal of this video. Let's get access to all of these DOM elements programmatically with this useElementApi function. So the first one is the single element. And to get access to that one, we're going to say const element API equals useElementApi, and we're going to call the function with no options at all. It does have an optional argument. We'll see how that works in just a sec. But first, we will just create that basic element API. It's the default one if you call this function with no arguments. And now that we have the element API object, we'll see in a little while what other properties it has. But for now, we're just interested in taking this. Is it right here? Yeah, it's right here. So we're going to bind to the ref attribute of this particular element. We're going to bind elementAPI.ref. So this .ref, this is a function ref. And we can bind this function ref that useElementApi has created for us and stored on this object here. We can bind this function ref to the ref attribute of this particular element, and then we'll get access to it in the DOM. And actually, let's log that out. So let's grab onMounted from Vue, because if you remember, if you've watched the other series, you know that, or if you've done any work with template refs in general, you know that you can't actually access DOM elements until the component has been mounted. Like, even if we're not using function refs, so we're just using standard template refs, which are much maybe more common, you still can access those elements until the component itself is mounted. So here, what we'll do is we will console.log element, and we'll console.log element API.element.value. That's the other thing to know about this object. So yeah, maybe backing up a little bit. useElementApi returns an object. Element API is an object, and it has two properties. Those properties are ref and element. The ref we bind to the element that we want to get access to its ref attribute. So we do :ref equals elementAPI.ref, and then we have elementAPI.element. That is a reactive reference to the DOM element itself. So with this onMounted console.log elementAPI.element.value, this should be logging that div to the console. And let's flip over to this screen, reload, and yeah, we can see here that the div is getting logged, and that is the same div. So perfect, that one's working. Now let's move on to the next challenge, which is getting access to this list. To do that, we're going to say const list API equals useElementApi, and we will call that with the optional parameter. And in that optional parameter, we'll specify the kind. It's an object, and we'll set the kind property to list. So useElementApi kind list. That tells this element API, okay, we're capturing a list of like v4 rendered elements basically. And so this list API thing that is returned from the function is also an object. It has one additional property compared to the basic element API. Maybe we'll look at that a little bit later. But for now, we'll just bind to the ref attribute of this v4 rendered element. Let me check. Yeah, this is the right one. So v4 item, index, and list metadata. We can take this index that we're getting from v4, and we can bind to the ref attribute of the v4 element. We can say list API.getRef and pass in the index. And I think I covered this in the original function ref series, but this pattern I call a function ref getter. So this getRef function, it returns a function ref. And it uses the index basically to retrieve the correct function ref for whatever element we're currently dealing with. This is definitely where things start to get a little bit confusing with function refs, but it's really cool and powerful once you go over this a few times and kind of get used to it. So we are basically getRef returns a function ref, and that function ref gets bound to the ref attribute of v4. And basically all of that works together so that this is all you have to do to now have programmatic access to all the elements in this rendered list that we have on the screen here. So to prove that, again, let's console.log. So we can console.log and we'll say list, and then we'll do list API. This one's a little bit different. It's not a single element, so it's elements plural with a S on the end. And then, but it's the same pattern, right? Where you just access list API dot elements dot value. It's a reactive reference. In this case, instead of holding a single DOM element, it holds an array of DOM elements. And with that done, we can flip over to the other screen, reload here, freshen things up. And yeah, now you can see we've got rendered to the screen list. I think these are just like stack blitz related errors. Nothing to worry about there. List. And then we have our array here. And if I hover over, you can see we have captured each individual DOM element, and they're listed in order that they render. So the first one is always stored at the first position in the array, and so on and so forth. That's the really cool thing about useElementApi is it does all this kind of management for you under the hood. It also takes care of if this isn't a list that could be reactively reordered, like drag and drop, or some other filter or sort button that is reactively reordering this array and changing like the way V4 renders over these things and renders them out. This array is always going to keep the exact order of the way things that are rendered. So if this third element actually gets rendered first, it will be on the next update cycle of Vue, it will be in that correct position. So this array is always guaranteed to be in the exact same order as everything that you have in the DOM. So those are definitely the two most commonly used ones. And then finally, let's take a look at this plain data structure, which is less commonly used, but really, really tricky to figure out if you don't have something like this useElementApi tool to do the work for you. So we call this with useElementApi. We pass in the optional parameter, and we set kind to plain instead of setting it to list. And then just to show you, I guess, just to illustrate what this could be, the default here is kind element. So we'll make that more explicit here. Kind element returns the element API, kind list returns the list API, and then kind plain returns the plain API, which again is a object. And just like the list API, it has a getRef property. But this one, instead of just accepting a single index, you actually have to pass in two indices. So you have to pass in the row index and the column index. So this plain API is very much designed to be used with these kind of nested for loops where you can get the row index from the first V4, and then you get the column index from the second V4. So we can pass that to plain API.getRef, call it with row index and column index. This function, getRef, is returning the correct function ref to bind to this ref attribute. And magic happens behind the scene with useElementApi. And basically what we get at the end is a really nice clean data structure with all the elements in order. So we can come down here, just like we did with the other ones, and log out plain, and we'll do plain API.elements.value, just like list API. This one is elements plural, but you'll see when we flip over, did I break something? No, I think we're good. Reload again, and okay, so here we go. We've got our element, single element. We have our list rendering out an array of elements. The plain renders an array of arrays of elements. So the top level array you can think of as like an array of rows in your table, in your grid that you're rendering. Each individual array inside of that is an individual row. So if we open up this first item here in the top level, the plain array, here's that div and this one and that one. So each of these individual arrays contains all the elements for the cells that are in that row. So this is the data structure that I use to work with these kind of grid data structures. It's certainly not the only solution you could go for. It's the solution that you'll get back from useElementApi if you choose to use that. If you're interested in kind of doing your own custom thing, then yeah, you could absolutely check out the internals of useElementApi and store them in a different way, like in a map or an object or anything like that. You really can do anything you want with these. I just find the array of arrays to be the appropriate data structure for most of my use cases. Final detail here that you will notice is that it has this plain It's logged in the console as a plane. This actually is just a normal array under the hood. Plain is a custom class that I made, but it's just a direct subclass of array with no modifications at all. So really the only reason I use that is so that I can say, I can do checks like if elements.value instance of plain, and that tells me, oh, is this like this array a thing that I'm getting back? Is this an array just of elements, or is this an array of arrays of elements? And so that's just a quick workaround that I do internally inside of this Polyada features library to help me work with that data structure better. So, but yeah, you can on this plain thing, like on elements.value here, plain API.elements.value, I can call .map, .filter, whatever. This is literally just an array. Think of it as an array that happens to have a different signature when you use instance of to check what type of class it is. So that I think pretty much covers it. Again, planes are more advanced, less commonly used. Mostly what we're going to be looking at in this series is single elements and rendered lists of elements. We're going to hit both of those pretty heavily because really that's like the most common thing that you work with in any application. So getting access to those elements, being able to do things with them programmatically inside of composition functions, whether it's focusing elements or adding event listeners to them, all of that stuff is super fun, super easy to do once you get the hang of this, and leads to really clean code and more performant code as well. And we'll get into the details of why and how that all works in future videos. So that's useElementApi. That's the overview of the series. And I hope to see you in the next episodes. I don't know how many there will be, but it should be fun. So I'll see you in the next ones.